Let's take the next example now, which is based on the principle of mathematical induction. So let's take the example. If A is a non-zero real or complex number, use the principle of mathematical induction to prove that if A equal to A 1 0 A, then A power n equal to A power n A power n minus 1 0 A raised to power n. Now for every positive integer n, for every positive integer n, now the solution, now by the principle of the mathematical induction is, now if the statement is true for n equal to 1, then it will now it is true for n equal to m. So if it is true equal to n equal to m, so it will be true for n equal to m plus 1. Now when n equal to 1, n equal to 1 means a1 is a1 1 into 1 minus 1 0 a1. Now the a1 is a power 0 0 a. Now it is equal to the a, so it is true for n equal to 1. The result is true for n equal to 1. Let the result be true for n equal to m, then a power m equal to a power m into a power m minus 1 0 a power m. So we will show that the result is true for, now we will show that the result is true for n equal to m plus 1. Now this is, so a power m plus 1 equals to a raised to power m plus 1. Now m plus 1 into a power m plus 1 minus 1 is a power m 0 a power m plus 1. Now by the definitions of the integral power of square matrix is a power m plus 1 equal to a power m into a. So a power m is a power m 0 m into m power minus 1 a power m. Now the matrix A is a 1 0 a. So a power m plus 1 equal to a power m into a plus 0, then a power m plus a into m a power m minus 1 0 plus 0, then it is a power m into a. So we get a power m plus 1 0 m plus 1 a power m, or it is m plus 1, a power m plus 1. So the result is true for n equal to, the result is true for n equal to m plus 1 whenever it is true for n equal to m. Now let's take the next example. If a equal to 0, 1, 0, 0, then prove that ai plus ba whole power n equals to a power n I plus n a power n minus 1 b a, where I is the unit matrix of order 2 and n is a positive integer. Now the solution by the principle of mathematical induction when n equal to 1. So it is ai plus ba equals to ai plus a power 0 ba. So sorry, it is n equals to 1. So now it is true for n equal to 1. Now the result is true. Now the result be true for n equal to m. Now the when n equal to m means ai plus ai plus ba whole power m is equal to a power m I plus m a power m minus 1 b a. Now the result will be true. The result will be true for n equal to m plus 1. The result will be true for n equal to m plus 1. Now if the n equal to m plus 1 means ai plus ba whole power m plus 1 is equal to a power m plus 1 I plus m plus 1 into a power m b a. By the definition of the integral power ai plus ba. Now solve the LHS. Now ai plus ba whole power m plus 1 we can write like as ai plus ba whole power m into ai plus ba. Now here by using this equation ai plus ba whole power m equals to a power m I plus m a power m minus 1 b a. So put here a power m I plus m a power m minus 1 b a into ai plus b a. So if we solve this equation, so we get the ai plus ba whole power m plus 1 is equal to a power m plus 1 I plus a power m ba plus m a power m b a plus m a power m minus 1 b square a square. Then a power m plus 1 I, then take the common m. Now take the common, sorry, a power m a. So we get m plus 1 plus m a power m minus 1 b square a square. Now if now the a square is equal to the a into a, so a is given 0 1 0 0, so it is also 0 1 0 0. Now if we multiply these two matrix, then we get the null matrix 0 0 0 0 is null matrix. So a square equals to the null matrix. So ai plus ba whole power m plus 1 equal to a m plus 1 I plus a power m b a m plus 1 plus m a power m minus 1 b square null matrix. At the end of we get the result is ai plus ba whole power m plus 1 is equals to a power m plus 1 I plus m plus 1 a power m b a. Now the result is true for n equal to m. That the result is true for n equal to m plus 1 whenever it is true for n equal to m. Now let's take the next example. If a equals to 1 1 1 1 1 1 1 1 1, then prove that a power n equal to 3 power n minus 1, 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 3 power n minus 1. For every positive integer n. Solution. Now when again this problem is solved by using the principle of mathematical induction when the n equal to 1. So a power 1 matrix power 1 is the 3 power 0 is 1, 3 power 0 1 1 1 1 1 1 1 1 1. So this result is true for n equal to 1. Then the result be true, the result be true for n equal to m. So a power m equal to 3 power m minus 1, 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 3 power m minus 1. Now the result is true for n equal to m. The result will be true for n equal to m plus 1. So a power m plus 1. So it is 3 power m, 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 3 power m. Now solve the left hand side. Now the a power m plus 1 we can write like as a power m into a. So a power m is 3 power m minus 1, 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 1 1 1 1 1 1 1 1 1. Now if we multiply these two matrices, now if the 3 power m minus 1, now the 3 power m minus 1 is multiplied with 1. Now again 3 power m minus 1 is multiplied with 1, 3 power m minus 1 is multiplied with 1. So we get the 3 times of 3 power m minus 1, again the 3 times the 3 power m minus 1, again the 3 times of 3 power m minus 1. Now similarly in the second row, 3 times of 3 power m minus 1, 3 times the 3 power m minus 1, 3 times the 3 power m minus 1. In the third row is same, 3 into 3 power m minus 1, 3 into 3 power m minus 1, 3 into 3 power m minus 1. So the a power m plus 1, a power m plus 1 is 3 power m, 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 3 power m. Now the result is true. The result is true for n equal to m plus 1 whenever it is true for n equal to m. Now let's take the next example. Under what condition is the matrix equation, under the what condition is the matrix equations a square minus b square equal to a minus b into a plus b is true. Now solution for this, now the a square minus b square is a minus b, a plus b. Now the a minus b is multiplied with a plus then a minus b is multiplied with b. So it is a square minus ba plus ab minus b square. Now a square minus b square. So the a square to a square is cancelled, minus b square to minus b square. So minus ba plus ab equal to 0. So ab equal to ba means the given matrix equation is true. The given matrix equation is true if the matrix A and B commute with each other. Now let's take the next example, which is based on the principle of which is based on the application of matrix. Now the next example, use the matrix multiplication. Use the matrix multiplication to divide rupees 30,000 in two parts such that the total annual interest at 9% on the first part and 11% on the second part amounts rupees 3060. Solution. Let's divide into the two parts. Now the amount is divided into two parts. So part 1 is x. So second part is 30,000 minus x. Let the amount is divided into the two parts. So matrix A is A x into 30,000 minus x. Now it's a part 1 or it's a part 2. Now the matrix R is represent to annual interest rate. So it's again divided into the two parts. So R equals to 0.09 or 0.11. Now the total annual interest on the two parts is given by the matrix multiplication AR. Now AR equals to 3060. So A is x, 30,000 minus x is multiplied with 0.09, 0.11 is equal to 3060. So it is 0.09x plus 0.11, 30,000 minus x equal to 3060. So the 0.9x we can write like it's a 9 by 100x plus 11 by 100, 30,000 minus x equal to 3060. So after the simplification we get x equal to 12,000. So hence the amount is divided into the two parts. So part 1 is the 12,000. So the second part is 30,000 minus x is 30,000 minus 12,000 is 18,000. So now in the next lecture we will continue with the transpose of matrix.